Vermicomposting is the process of converting biodegradable farm wastes and other household wastes into compost or organic fertilizer through the action of earthworms. It is also a scientifically based proven technology because many scientists in the world have attested to the efficacy of vermicompost. It is low cost and low tech because it only uses materials that are abundant and easily available, and the procedure is very simple. The benefits of vermicompost are: it improves the water holding capacity, aggregation, and porosity of the soil. It is an alternative source of organic manure and substitute for chemical fertilizer on different vegetable crops. It is rich in bacteria, actinomycetes, and fungi, and it improves the soil's physical structure and enriches the soil with microorganisms that adds enzymes such as phosphatase and cellulase. It enhances germination, plant growth, crop yield, and root growth. It is important to note that the proximity to source materials, availability of water, flood-free, and accessibility are the basic elements in order to do the steps in vermicomposting. The 5 steps in vermicomposting are: gathering and sourcing of materials or substrates, preparation of materials or substrates, thermophilic or anaerobic decomposition of substrates for 14 or more days, aerobic decomposition or vermicast production in 30 to 60 days, and harvesting, which includes vermicompost and earthworm biomass. Gathering and sourcing of materials or substrates. Locally available and low-cost organic farm wastes or biodegradable market wastes such as crop residues, livestock wastes, grasses, leaves of leguminous trees, sawdust, and cocoa coir dust. Substrate with the ideal percentage of carbon source is 40% to 75%. Substrate with the ideal percentage of nitrogen source is 25% to 60%. Preparation of materials or substrates. Vermibed dimension varies in length, 3 to 10 meters, and width of 1 to 2 meters, depending on the available budget and convenience. Vermibed package: 2 layers of hollow block cemented sidings and uncemented bottoms. Shred or chop the materials for faster decomposition by increasing the surface area available for microbial action. Place properly mixed materials or substrates in the bed at 50 kilograms per square meter. Cover with plastic sheet or several layers of banana leaves to initiate thermophilic or anaerobic decomposition. Temperature of the fermenting materials can go up to 70 degrees centigrade. Let it stay for 2 weeks for pre-decomposition. After 2 weeks or more, remove plastic sheet or banana leaves. Apply Trichoderma harzianum to hasten decomposition. Pre-decomposition of substrates can also be done without plastic sheet cover by allowing the shredded or unshredded substrates to undergo the usual and longer decomposition period, provided the substrate is not urgently needed for feeding of African nightcrawler. Stocking of the African nightcrawler or ANC. After the pre-decomposition, the ideal temperature and moisture of material substrates should be checked prior to the stocking of the ANC. Odor of the bedding should be sweet-smelling and not pungent. Sprinkle the bedding materials with water to lower the temperature. Ideal stocking density of ANC is at 1 kilogram. 1 kilogram of worm grows to 30 kilograms after only 6 months. Care and maintenance. Shed is important to control too much water from rain. The setting up of perimeter fence is also recommended. Timely harvest of the ANC is important to avoid ANC losses that build up waste and migration. Upon stocking ANC, cover the vermi beds, preferably with framed kalakat or framed bamboo at manageable length to simulate night environment for ANC and prevent the entry of chicken, toad, and others. Another option is to cover it with banana leaves or coconut fronds and secure it with a plastic nylon net. Eliminate centipedes and beetle grubs. Place nylon net for protection against predators. Water the beds as needed to maintain moisture level of 60% to 80%, particularly during the dry season. A practical way to check moisture is to squeeze a substrate sample of the bedding in one hand and observe the amount of drops of water. 3 to 5 drops is just right. A moisture meter can also be used for accurate measurement. Harvesting, processing, and packing. Timely harvest of the ANC is important to avoid its loss due to buildup of waste and migration. Stop watering the beds 5 to 10 days before the harvest. Depending on the biomass stocked and the quality of the bed materials used, the vermicompost in the beds can be harvested after 30 to 45 days as soon as the granular form of thick vermicast is visible. The ANC may also be transferred or induced to migrate to a previously prepared bed with substrate. To achieve the ideal moisture of 30%, air dry the vermicompost on the concrete floor or laminated matting under a shed. Sieve the vermicompost manually or mechanically to separate the coarse and fine materials. The initial sieved vermicompost can be stored for 2 weeks, then cover it with a net. Second sieving of vermicast is recommended to make use of the newly hatched or young ANC before bagging. Initially pack the sieved vermicompost in plastic bags and then pack it in sacks for the final packaging for longer storage.